Hello students, the question is charge is distributed within a sphere of radius capital R with a volume charge density rho equals to a by r square e to the power minus 2r by a, where capital A and small a are constants. If capital Q is the total charge of this charge distribution, the radius capital R is. Here the charge is distributed within a sphere. Let the sphere is this. The distribution is not uniform because the volume charge density is given as rho r. It means that the volume charge density is a function of r equals to a by r square e to the power minus 2r divided by a. Capital A and small a are constants. Here smaller is nothing but this distance, and the total radius of this sphere is capital R, and total charge contained in it is capital Q. Okay. Now we have to consider a spherical shell of radius r and thickness dr like this. So it has a thickness of dr. Therefore this is the hemispherical shell of radius r and thickness dr. Now we have to first find the volume of this annular sphere. So volume of the annular sphere or spherical shell. Volume of the spherical shell is nothing but 4 pi r square into dr, that is area into thickness. There is another way of finding this thing. You can also find dV like this: 4 by 3 pi r plus dr whole cube minus 4 by 3 pi r cube. Taking 4 by 3 pi common, we get r cube plus 3r square dr plus 3r dr square plus dr cube minus r cube. So r cube will cancel out. Now we can neglect this thing and this thing because both are equal to 0, because dr is very small, so we can neglect dr square and dr cube. Therefore we get 4 by 3 pi into 3r square dr, which is nothing but 4 pi r square dr. You can see we get the same result. Okay, this is the volume of the spherical shell of radius r and thickness dr. Now we have to find the charge enclosed in it. Okay, charge on that spherical shell. It is very simple. Charge is what? Volume charge density, that is rho into dV. Rho is what? Volume charge density. Volume charge density means charge contained per unit volume. So if I multiply rho with dV, we get the charge contained in this spherical shell, right or wrong? In this shaded portion. Okay. So putting rho there, we get a by r square e to the power minus 2r by a into 4 pi r square dr. R square goes out. Therefore we get dq equals to, if you look at this equation, 4 pi into capital A, 4 pi capital A e to the power minus 2r by a into dr. You can verify this answer, a to the power minus 2r by a into dr. Now This is the charge enclosed in that spherical shell only. Therefore total charge is nothing but integration of this. 4 pi a is constant minus 2r by a dr. The limit should be 0 to capital R, because if you look at this, this is r, this is dr. Therefore the minimum possible radius of this shell would be 0 when it is here, and the maximum possible radius of the shell will be capital R. I hope you understand. Now integrating 4 pi a e to the power minus 2r by a divided by minus 2 by a. The limit should be 0 to capital R. I hope you understand. That is minus 2 pi small a capital A. This is e to the power minus 2 capital R by a minus e to the power 0. E to the power 0 is 1. Therefore I can say q is 2 pi small a capital A e to the power 0 is 1 minus e to the power minus 2r divided by a. I hope you understand. Now in the question they ask you for capital R. Therefore I can say this is. Now proceeding to the next slide, e to the power minus 2r by a equals to 1 minus q by 2 pi small a capital A, right or wrong? Therefore taking log on both sides, see here I take natural log, that is log to the base e. So this thing is minus 2r by a equals to log 1 minus. Therefore I can say 2r by a equals to negative of log. Now I can replace negative of log by this. I can replace this thing as minus ln 1 minus q by 2 pi a, that is r equals to a by 2 log 1 by 1 minus q by 2 pi a. Now I hope you understand. Therefore the answer is option 2, a by 2 log 1 divided by 1 minus q by 2 pi a. So correct option is option 2. Thank you for watching this video. Please subscribe my channel Phi Solver.